The discovery of an oversized planet that orbits a sun has disrupted existing models of solar system formation. Greetings to everyone. Today's video focuses on a groundbreaking discovery made by researchers at Penn State University. They have found an unusually large planet orbiting an ultra-cool dwarf star, which challenges current theories on how planets are formed. This planet, known as LHS 3154b, is more than 13 times the size of Earth, while its host star is 9 times smaller than the Sun. The mass ratio between the planet and its star is over 100 times greater than that of Earth and the Sun. This remarkable finding raises fundamental questions about the formation of planets and stars, and the researchers consider it to be an extreme test case for existing theories on planet formation. Without further delay, let's dive into our discussion. According to researchers from Penn State, the recent identification of a planet that exceeds the expected mass in relation to its sun is challenging existing knowledge regarding the formation of planets and their respective solar systems. Today, a team of researchers published a paper in the journal Science unveiling their groundbreaking finding of a planet that surpasses Earth in mass by over 13 times. This newly discovered planet orbits a star known as LHS 3154, which is classified as ultra-cool and is 9 times less massive than our Sun. What sets this planet apart is its remarkable mass ratio, which is over 100 times greater than that of Earth and the Sun. This discovery presents the largest planet ever observed in a tight orbit around an ultra-cool dwarf star, which is one of the smallest and chilliest stars in existence. This finding challenges prevailing theories about how planets form around small stars and represents the first instance of a high-mass planet being detected in orbit around a low-mass star. According to Suvrat Mahadevan, the Vern M. Williman Professor of Astronomy and Astrophysics at Penn State and co-author of the paper, this finding truly emphasizes our limited understanding of the cosmos. The existence of a planet of this magnitude orbiting a star with such minimal mass is beyond our expectations. The process of star formation begins with the condensation of gas and dust within vast clouds. Once a star has formed, the remnants of gas and dust form swirling disks that encircle the newly born celestial body. Over time, these disks have the potential to evolve into planetary systems. According to Mahadevan, the presence of a planet in the planet-forming disk surrounding the low-mass star, LHS 3154, defies expectations, as the disk was believed to lack sufficient solid mass for planet formation. This discovery calls for a reassessment of our current knowledge regarding the processes of star and planet formation. Using a specialized astronomical spectrograph called the Habitable Zone Planet Finder, HPF, a group of scientists led by Mahadevan at Penn State successfully identified a massive exoplanet known as LHS 3154b. The primary purpose of the HPF instrument is to locate planets that revolve around the coldest stars beyond our solar system, specifically those that have the potential to sustain liquid water on their surfaces, a crucial element for supporting life. Detecting planets around stars similar to our Sun is a challenging task, but the cool temperature of ultra-cool stars brings planets with the potential for liquid water much closer to their star compared to Earth and the Sun. This proximity, coupled with the ultra-cool star's low mass, creates a noticeable signal that confirms the existence of these planets, as Mahadevan clarified. According to Mahadevan, envision the star as a campfire. As the fire's temperature decreases, you must move closer to it to maintain warmth. This concept applies to planets as well. When a star is colder, a planet must orbit closer to it in order to maintain a suitable temperature for liquid water. By observing a slight alteration in the color of the star's spectra, or light caused by the gravitational pull of an orbiting planet, we can detect the presence of a planet with a sufficiently close orbit around an ultra-cool star. The HPF, situated at the McDonald Observatory in Texas, offers exceptionally precise measurements of infrared signals emitted by nearby stars, making it one of the most advanced instruments of its kind. Having the privilege of making this groundbreaking discovery using HPF holds a special significance for us. HPF is an innovative instrument that we meticulously designed, developed, and constructed specifically to explore the unexplored realm of planets revolving around the smallest stars, expressed Gudmundur Stephensen, NASA Sagan Fellow in Astrophysics at Princeton University and the primary author of the paper. Stephensen, who contributed to the development of HPF and actively participated in the research during his time as a graduate student at Penn State, further stated, "Now we are reaping the benefits of our hard work, uncovering novel and unforeseen aspects of this captivating population of planets encircling some of our closest neighboring stars." Stephensen highlighted that the instrument has already provided crucial data in the identification and verification of previously unknown planets. However, the revelation of planet LHS 3154b surpassed all initial predictions. Megan Delamer, a co-author on the paper and astronomy graduate student at Penn State, expressed her enthusiasm about the discovery, stating that based on ongoing survey work with the HPF and other instruments, it is highly probable that an object similar to the one they found is exceedingly uncommon. She further added that the detection of this object has been incredibly thrilling. Moreover, she pointed out that the current theories surrounding planet formation face significant challenges in explaining the observations they have made. According to Delamer, the team's measurements of the massive planet orbiting the star LHS 3154 suggest the presence of a substantial planetary core. This core, however, challenges current models, as it would require a greater amount of solid material in the planet-forming disk than predicted. Additionally, this discovery raises questions about previous understandings of star formation. The dust mass and dust-to-gas ratio of the disk surrounding young stars like LHS 3154 would need to be 10 times higher than observed in order to form a planet of comparable mass to the one found by the team. According to Mahadevan, our recent findings serve as a highly challenging scenario for all current theories on the formation of planets. This is precisely the purpose for which HPF was designed, to unravel the mysteries surrounding the birth of planets around the most prevalent stars in our galaxy and to uncover these planetary bodies. The additional authors from Penn State who contributed to the paper include Eric Ford, Brianna Zawadzki, Fred Harty, Andrea Lin, Lawrence Ramsey, and Jason Wright. Joining them are Joshua Wynn from Princeton University, Yamila Miguel from the University of Leiden, Paul Robertson from the University of California, Irvine, and Ray Holcomb from the University of California. Other contributors are Shubham Kanodia from the Carnegie Institution for Science, Caleb Canas from the NASA Goddard Space Flight Center, Joe Neenan from India's Tata Institute of Fundamental Research, Ryan Terrian from Carleton College, Brendan Bowler, William Cochran, Michael Endel, and Gary Hill from the University of Texas at Austin, Chad Bender from the University of Arizona, Scott Diddams, Connor Frederick, and Andrew Metcalf from the University of Colorado, Samuel Halverson from the California Institute of Technology's Jet Propulsion Laboratory, Andrew Monson from the University of Arizona, R. Peter Roy from Johns Hopkins University, Christian Schwab from Australia's Macquarie University, and Gregory Zeiman from the Hobby Eberly Telescope at UT Austin. Funding for the project was provided by a range of organizations, including the Center for Exoplanets and Habitable Worlds at Penn State, the Pennsylvania Space Grant Consortium, the National Aeronautics and Space Administration, the National Science Foundation, and the Heising-Simons Foundation. To support our channel's growth and ensure broader awareness, kindly hit the like and subscribe buttons. This will help us reach more individuals and disseminate valuable information. Thank you in advance.